I welcome you all to the fourth lecture series of blockchain technology. So today I will take a very important topic which forms a essential aspect of blockchain technology. So the topic I will discuss today is cryptography. So so what cryptography is? So in a very simple sense, I would say cryptography is a technique to transmit a secret message in a such a way that the message is in unreadable form, so that any intruder or any person who is unauthorized is not able to read that message, right? So we make the message in unreadable form using cryptography technique, and the cryptography involves encrypting the message, or we call it as hiding the message, and it involves a reverse process also, because once we send the message in unreadable form, the receiver should be able to retrieve the message in original form. So the first essence of cryptography technique is, we call it as encryption. So if I explain encryption, so this is the process of hiding the message. So, or one can say, or making a message in unreadable form, right? So I will give you a simple example out here. Suppose I want to send a password, right? Let us say the password is Tom, right? So I want to send a password to one of my friend, and the password is Tom. So I want that any unauthorized person who happens to catch this message, he should not be able to what to say, to extract the message, right? So what I will do is I will make this message to hide. So one simple logic I will take out here is, I will replace every letter of this word Tom by next subsequent letter, right? So next subsequent letter of T, I will replace a T by its next subsequent letter. So next subsequent letter of T I can say is U. Then what I will do is I will replace letter O, right, by its next subsequent alphabet. So next subsequent alphabet of O is P. Similarly, I will replace the alphabet M by its next subsequent alphabet. So the next subsequent alphabet of M is N. So what I did is I uh, I converted this message, right, to some another form, right, using the logic that I will replace every alphabet of this word Tom by its next subsequent alphabet, right? So this way what I am doing is I am hiding my message, and this process we call it as encryption. So in technical terms, this original message, we call it as plain text. So this original message we call it as plain text, and this resulting message after applying encryption process, we call it as cipher text. Right? Now in this encryption process, we used the logic where we replaced every alphabet of word Tom by its next subsequent alphabet. So this logic, or this algorithm or this methodology using which we encrypted our plain text, we call it as key. So key is nothing but it is the it is the it is nothing but it is the algorithm for encrypting the plain text, right? So here I can say in a short way I can say that key is equals to the alphabet, right, position plus next position plus 1, I would say plus 1, right? So whatever alphabet position is, then the key is we transform the alphabet to to another alphabet by its plus 1 position, right? Now what we did here, we converted this word Tom, which I said is a password, right, into encrypted form, and this encrypted message, that is UPN, we will transmit to the receiver, right? So the sender encrypted the password Tom and transmitted to the receiver. So once receiver receives this ciphertext UPN, then the receiver must be able to get back the original message, right? Because then only he will be able to know what is the true password. Okay, so the reverse process of encryption, we call it as decryption. We call it as decryption, right? So in simple sense, decryption, so this is the process of converting ciphertext, or we say encrypted message, to plain text, right? Now, so I have the ciphertext UPN, which has been received by the receiver, and we have to convert back into the original message or the plain text. Now, what logic we will use? So it is quite simple. To get back the original message, we will replace each alphabet by the alphabet one position before, right? So one position before U is T, one position before P is O, and one position before N is M, right? So here if you observe that we are using similar key for encryption and decryption. The key is one position, right? So the receiver and the sender knows that for encrypting, the key is that each alphabet of the plain text is replaced by the one position of the subsequent letter or subsequent alphabet. So in nutshell, cryptography consists of two aspects. One is encryption, another is decryption, right? Now, there are two types of, broadly speaking, two types of cryptography techniques. One we say symmetrical cryptography. So this is one type of cryptography technique. So as the name sounds, we can easily guess what is the symmetrical cryptography technique, right? So in symmetrical cryptography technique, we use same key for encryption and decryption. So the encryption and decryption process we discussed just now is actually symmetrical cryptography. And the second type of cryptography technique we have is asymmetrical cryptography. So the name sounds, here we use different keys for encrypting and decrypting the message. And this asymmetrical cryptography is actually the main point of concern in this present lecture, because in case of blockchain technology, we use asymmetrical cryptography, right? So I will go ahead with asymmetrical cryptography now. So as I already explained, that in asymmetrical cryptography, basically what we do is we use different keys for encrypting and decrypting the message, right? So the senders encrypt the message with one key and decrypts the message. The receiver decrypts the message with another key, right? So this asymmetrical cryptography is one of the main important component for implementing the blockchain technology, right? So once I proceed in the syllabus, I will explain in what sense we use asymmetrical cryptography in case of blockchain technology, right? So I will rub this text, and then I will proceed. All right. So now what we have out here is, in say asymmetrical cryptography, we also call asymmetrical cryptography as public key cryptography, right? Public key cryptography. All right. Okay. So this is another name of asymmetrical cryptography. So what happens out here is, suppose if I have a message M, right, and I have key K. All right. So what I do is I encrypt this message with key K. So I get the cipher message or cipher text, let us say, as M dash. So M dash is nothing but it is cipher text. So we say M dash is nothing but is equals to encryption of message M with I would put comma here with key K, right? So this results in ciphertext, right? Okay. Now what we have here is we have the ciphertext M dash, and we need to get the original message M, right, from this ciphertext. So this process we have is encryption. Okay, right. So here I will write out here specifically. I will call it as key 1, right? I will call it as key 1. Then I would decrypt this message M dash. So what I will do is, for decrypting this message, right, I will call it as process D. I have M dash comma key 2, right, and I get back the original message M, right? So this process I call it as decryption. So here if you observe, I have message M, I am encrypting it with key K1 and I get the resulting ciphertext as M dash, right? And then I get message M from the ciphertext M dash using key K2, right? So if you observe here that in this case I am using two different keys for encrypting and decrypting the message, right? So such type of cryptography we call it as asymmetrical cryptography, right? So in case of public key cryptography, we call these two keys, instead of calling it as K1 and K2 key, we call it as public private public private key. Public private key. Now I will explain what public private key means. Now, as the name sounds, what is the meaning of private key? So this is the key uh, which is which is not available to everyone, right? And public key is one which is available to everyone, right? So in public private key cryptography technique, or we call it as public key cryptography technique, what we do out here is that we suppose if I have a person A, right? We call it as Alice, right? So this person A, Alice, he wants to transmit message M, right? Alice wants to transmit message M, right? So what Alice does is Alice encrypts message M with its private key, right? So this key is available only with Alice, right? So this key is private to Alice, okay, right? So this key is private to Alice. Now there is the public key, a public key, right? Which is a private public key pair, which is a private public key pair. What is the meaning of private public key pair? It means that if k private is the private key with Alice, right? Then if anyone wants to decrypt this message M dash, right? Okay, then anyone having the corresponding public key pair of this private key will be able to decrypt this message, right? Okay, will be able to decrypt this message. Let me call the public key pair as k public, right? So these two are pairs in the sense that you encrypt the message with k private key and you decrypt the message with k public key. Of course these two keys are different, they are not same. That's why we call it as asymmetrical cryptography, right? So again I will take the same scenario. Alice has message M, right? This Alice encrypts the message, right, with its private key and transmits it, and whosoever is having this public key pair of this private key will be able to decrypt the message. Now I just told you that public key is available to everyone, right? So everyone will be able to decrypt the message M and will be able to obtain M back from this ciphertext M dash using the public key, right? Now someone may ask me that here the message I am encrypting is available to everyone, right? So this is very and what to say, it's very strange, right? Because we want to hide the message from everyone, but here we are encrypting the message with a secret key, and anyone with public key of this corresponding private key will be able to decrypt the message, right? So there is no point of secrecy here, right? But this methodology that I have just shown you is used for digital signature. Specifically, this is nothing but I would specifically say this technique, we call it as cryptographic digital signature. Sorry, it's not signal, it's wrong. So it's cryptographic digital signature. So what does it mean? Suppose I am going to a bank, right, and I submit a check. Okay, so whenever you submit a check in bank, you of course you sign it, right? So the sign that you use is your secret key, right? But anyone can authenticate from your signature that this check has been signed by you, right? Okay, so basically when we are encrypting the message with private key and we are transmitting the message to the public, anyone in the public having the public key will be able to decrypt this message m dash and retrieve the original message m. So this process authenticates that message m has been sent by Alice, because this message m has been decrypted by the public key which is paired to the private key which is with the Alice, right? Okay, so let us say we have various entities like Alice, okay, like Bob, right, like Tom. So we have various entities. So every entity is assigned public private key. So Alice will have its own public private key, Bob will have its own public private key, Tom will have its own public private key. So if Alice is encrypting a message with its own private key, then it cannot be decrypted with the public key of Bob. Similarly, if Bob is encrypting a message with its own private key, it cannot be decrypted with the public key which is paired with the private key of Alice or Tom, right? So the message which has been encrypted by Bob by private key, it can be decrypted only by the public key of the Bob, right? So this technique that which I have shown, this process which I have shown, where the encrypted message is made public, right, and everyone in the public domain with the public key of the Alice is able to decrypt the message. So this does what? This authenticates that this message M has been transmitted by Alice, right? So we have a term known as non-repudiation, which means that which means that Alice in future will not be able to deny that this message M has not been sent by Alice, right? Because this message has been decrypted by the public key of the Alice only, right? So non-repudiation means the denial, right? So here Alice will not be able to deny, right, that this message has not been sent by Alice. Okay, now let's look at its reverse process. Very interesting, right? So here we will look at the reverse process out here. So in reverse process, you can guess what we might be doing. We will encrypt the message with public key and decrypt the message with private key. We will just do something called as reverse process of what I have explained, right? So what I did just now, I have a person, Alice. Alice has its own public private key, right? Of course, this public private key is different. Alice encrypts a message with its private key and make the encrypted message or cipher message available to the public. Now the public key of Alice is available to everyone, so anyone can decrypt the message. So this process is used to ensure that this message has been sent by Alice, right? So it is in one way, it is nothing but it is a cryptographic digital signature, right? So when we put a signature on a document, it clearly authenticates that this particular document has been sent by the person who has signed the document. So it is in same way when we sign or when we encrypt a message with a private key and decrypt with its corresponding public key pair, it authenticates that the message has been sent by the person who has encrypted with its public key, oh sorry, private key, right? So we just now discussed cryptographic digital signature, right? Now we have reverse process, right? So let us say we have two entities now. I have entity Alice and then I have an entity Bob. Okay. Now Alice wants to send the message to Bob. Some message Alice wants to send to Bob, but here I don't want that. Here Alice doesn't want that. Whatever message Alice is encrypting, right? That message can be decrypted by anyone. No. Okay. So Alice wants that whatever message Alice wants to send to Bob, that message can be encrypted by Bob only and no one else, right? So again I repeat the scenario, right? I have a message which Alice wants to send to Bob in such a way that Alice encrypts the message, but the encrypted message cannot be decrypted by anyone but only Bob. Okay, so what Alice will do, right? Now Bob has its own private and public key pair. Alice has its own public and private key pair. So what Alice does, let us say we have message M which Alice wants to transmit to Bob. So what Alice does, Alice encrypts message M, right, with Bob public key, right? So when I write here KB public, it means Alice is using the public key of Bob to encrypt message M, and the resulting message I get as M dash. Okay, right? So now the public key of Bob is available to everyone, right? But the corresponding private key of Bob is available only to Bob. Okay, so now this message M dash, this ciphertext M dash, this one is in public domain now, right? This message M dash, it is available to everyone or it is in public domain. But to decrypt this message, I need the private key of Bob, right? Because here we are using public private key pair, two different keys to encrypt and decrypt the message. Earlier what we did, we encrypted the message with the Alice private key, right? And then we transmitted, right? So anyone having the public key of Alice, which is actually available to everyone, will be able to decrypt the message, and that will authenticate that this message has been sent by Alice. But here we are not using the concept of digital signature. Here we are trying to transmit the message in secret way. This is the different scenario. So what we do, we always encrypt the message, right, with a public key of the person to whom we want to send, right? If you're looking for sending the message in a secret way, right? So here I wanted to send the message from Alice to Bob. So what I did, I encrypted the message with the public key of Bob. So this encrypted message M dash is available in public, right? But only Bob will be able to decrypt this message M, right, from the cipher message M dash by using Bob's private key, right? So see, it's very interesting. We are in previous example also we used public private key. Here also we use public private key, but in previous example we were using for authenticating that the message has been sent by Alice. We are not in the interest of hiding the message, but we are in the interest of authenticated that this message has been sent by Alice. But in the second scenario which I have shown you, here we are interested to send the message in a secret way from one person to another. So here also we are using public private key pair, but here what we are doing is we are encrypting the message with the public key of the person to whom we want to send the message in a secret way, right? Now here comes the application of this cryptography technique in blockchain technology. In blockchain we have transactions, right, which is sent by one person to another. So let us say we have a transaction which Alice sends to Bob, correct? Okay, right. So for sending the transaction, what Alice does, Alice encrypts the message, right? Alice encrypts the message with its private key, right? So Alice encrypts the message or the transaction with its private key. So anyone in the public will be able to know that this transaction has been sent by Alice. So in future, Alice will not be able to deny that it has sent the transaction to the Bob, right? So in previous case we used digital signature. So in blockchain technology, blockchain technology actually uses digital signature, cryptographic digital signature, where we encrypt the person who wants to send the transaction. That person, he or she has to use public private key pair, where the person has to put a digital cryptographic digital signature on the transaction by using its private key, right? So that uh, anyone will be able to use the public key and will be able to authenticate that this transaction has been sent by Alice, right? So once the any person using the public key of Alice will be able to decrypt and will be able to know that transaction has been sent by Alice to the Bob, right? So this transaction has all the details that this transaction is being sent to whom and what amount, right? Right, and this detail can be revealed by using the public key of the Alice, right? So here I will stop. I hope the audience would have got bit of sense or bit of intuition why this cryptography technique is used in blockchain technology. So in next lecture I will take another important aspect of cryptography, which we call it as hashing. That is also a very important aspect that is used in cryptography. It is a one of the domain of cryptography. So I thank you all.